All right, guys, welcome to the notes on 9-1. We're going to look at graphing quadratic functions. All right, so lots of vocab here to make sure we're straight on how to do this. Um, Quadratic function, obviously, is a nonlinear and can be written in this form. This is called standard form. Ax squared plus bx plus c is the standard form for a quadratic. The shape of a quadratic is a parabola. It's this curvy-looking U guy down here. There's an axis of symmetry in a parabola that essentially cuts it in half. And the point where the parabola intersects the axis of symmetry right here is the vertex. It's like the turning point, okay? The parent function is x squared. The standard form is this. The shape is here. To find the axis of symmetry, we do that right there, and then the y-intercept is c. Parabola can have a maximum or minimum depending on which way it faces, and we'll talk about that. If it opens up, it has a minimum. If it opens down, it has a maximum. It's the lowest and highest point. That should seem make sense, and it's also the vertex. All right. So we're going to use a table of values to graph it. So we just pick some numbers and we get some points, and then we're going to talk about domain and range. So pick some numbers and get some points for y equals x squared plus 3. Sketch a graph of it, and then tell me the domain and the range. Go ahead and do that now. Pause the video and do that now. All right, you're back. I'm not sure what points you picked, but your graph should look something like this. Okay, it might not look exactly like mine, but it should certainly look something like mine. And then I'm going to connect this the best I can. I want to put an arrow because I got to understand that it goes forever. And then as far as domain and range, we're going to write that out like this. The domain here, whoopsie daisy. The domain is all reals because it goes forever in both directions. And the range is, and we can put these in these little fancy bracket guys. I'm going to show you how to write this. This is y, and then this is like a curvy e. It means that y is an element of the real numbers, okay? And then there's this line that means such that y is greater than or equal to 3. Okay, the big thing is this part right here, this y is greater than or equal to 3, and we'll get some practice. That's the big part. Y is greater than or equal to 3. We'll get some practice with this other part when my handwriting isn't so god-awful. All right, let's take a look here. Figures that possess symmetry are those in which each half of the figure matches. You guys know about symmetry. You've worked with symmetry for a long, long time. Okay, so we want to be able to look at a graph and identify some characteristics from it. The easiest thing to do is locate the vertex first. So for example, if we had to find the vertex, the equation of the axis of symmetry, and the y-intercept for each graph, it's just really looking at the pictures. You know, the vertex is this point right here. The axis of symmetry is the vertical line that goes through the vertex, and then the y-intercept is where it crosses the y-axis. It's not really that complicated, okay? Go ahead and take a second, too far, and do that for 2a and 2b. Find the vertex, the axis of symmetry, so vertex, axis of symmetry, which is an equation, remember, and the y-intercept. Go ahead and do that for A and B. Go ahead and do that now. All right, you've unpaused. Hopefully here you got negative 1, 3. The axis of symmetry is x equals negative 1, and the y-intercept is, whoops, that's a 1. And the y-intercept is 2. For 2b, hopefully you got the vertex is at 1, 3. The axis of symmetry is x equals 1, and the y-intercept was 4. If you didn't, try those again, look, and maybe you miscounted and still can't get them, make sure you make note of it so we can go over to or go over from class. How to find the vertex and the equation of axis of symmetry and the y-intercept from looking at it, okay, from the equation now, not just the graph. The axis of symmetry, that's found by using this. X equals the opposite of b over 2a. X equals the opposite of b over 2a. So I take the opposite of b and put it over 2 times a, and that equals x. Well, that's the axis of symmetry. I can take that, plug it in, and then I get the y value for the vertex. So now the vertex is negative 1, same as that, negative 1. And I plug the negative 1 in, I simplify, and I get negative 5. And then the y-intercept is at c, which is just this right here. Okay, easy enough. All right. Same thing here in example B. There were just some different signs, so make sure you're really careful about sign error. All right. Go ahead and take a second and try and get me same information, axis of symmetry, vertex and y-intercept for 3a and 3b. Go ahead and do that now. All right, for 3a, you're back. The vertex is 1, negative 2. The axis of symmetry is obviously x equals negative 1, and the y-intercept is at negative 5. For 3b, this is a little bit harder because it has fractions. Negative 1 half, 3 halves. The axis of symmetry is x equals negative 1 half, and the y-intercept was 2. Some basic things about the difference between lines and quadratics. Obviously, the standard form is different. The degree, these are 1, and then these are 2. Examples of both, and then what they look like. Okay, now we're going to talk about whether or not they open up or down, and this really just comes down to the A. If A is positive, it opens up and it has a minimum. If A is negative, it opens down and has a maximum. Okay, that's really it. So we're not going to do the example. We'll do this one together because this stuff's really simple. Let's go ahead and take a look. Let's see. Determine whether the function has a maximum or minimum. Well, this is positive, which means it opens up, so it has a min. State the maximum or minimum value. Okay, so now we're doing the same thing we just did to find the maximum or minimum value. This I will go back so you can look at. All we do is we use this opposite of b over 2a thing to find the x. We plug the x in to find the y. Okay, so the opposite of b over 2a. Well, b is negative 4, so that's positive 4, over 2 times 2, which is 4. So x equals 1. Then we're going to put the 1 back in to find the minimum value, because the minimum value is the y. So 2 times 1 squared minus 4 times 1 minus 1. You do all that, and hopefully you get negative 3. Right? And then, that's 2 minus 4 minus 1. That's negative 3. And then state the domain and the range. Well, the domain is all reals. Domain is all reals. Or we could say x is an element of the reals, and we'll talk more about this. The range is y is an element of the reals, such that y, and it's got to be, because it's a min, it means it's here, everything above it, so it's y is greater than or equal to negative 3. If it opens up, the range is greater than. If it opens down, the range would be less than. So how to graph a quadratic function? First, find the equation of the axis of symmetry. You find the vertex, you find the y-intercept. You use symmetry to find a couple more points if you need to, and then you're going to connect the dots. You just try to graph. You try to find as much as you can. Okay. I'm going to do one with you, and then you're going to do one on your own that we'll talk about in class. So let's go ahead and take a look at 5a. Hold on, let me throw something over here and make this. Okay, so let's find, for 5a, let's find the axis of symmetry. So that's x equals the opposite of b over 2a. So the opposite of b is negative 2. 2 times a would be negative 4. So the axis of symmetry is at 1/2. So I'm going to graph that. So that's right here. Okay. Then, let's see, the y-intercept is negative 1, so that's here, and graph that. The vertex, well, let's take 1/2 and put that in for x. Okay, so we take the 1/2 in, we have negative 2 times 1/2 squared plus 2 times 1/2 minus 1. So this is negative 2 times 1/4 plus 1 minus 1, plus 1 minus 1, those are goners. And then here, this is negative 2 times 1/4, which is negative 2/4, which is negative 1/2. So that's the y value. Let me straighten this guy out. So here's my axis of symmetry, and then if I go down to negative 1/2, that's the y value of the vertex, and then I can use the axis of symmetry to put a point there. If that's not enough for you, pick some more points. Like say we pick 2. Negative 2 times 4 plus 4 minus 1. So that's negative 8 plus 4 minus 1. So that's negative 4 minus 1, which is negative 5. So if I go to 2, I'm going to go down to 5. That gives me another point. I feel a little bit more comfortable now about graphing, and now that I have more points. So I connect my dots. And there's my graph. You try to do the same thing for 5b, and I'll get a volunteer in class to go over that one. Go ahead and pause the video here. You try 5b. We're not doing this one on the video. Pause right here. Try 5B. We'll go over it in class. Real world example of how we can use quadratics. The nice thing is that a lot of times on the real world problems, they're going to give you the formula and you just got to plug stuff in to figure things out. It's really not that hard. We've been doing stuff like this. We just haven't been telling you that this is what we've been doing. If we look at this problem right here, Emilio is competing in a javelin throw. The height of the javelin can be modeled by this equation, where y represents the height. Graph the path of the javelin. Okay, so you graph it in your graphing calculator. Just go ahead and put that in. At what height is the javelin thrown? Okay, so you're going to want to know what's the height at the beginning, and so that's the y-intercept. So that's just 6. That's easy. What's the maximum height? That I want you to try and put this in your graphing calculator, see if you can find it, or you could use x equals the opposite of b over 2a, and then find the y value based on that x. Go ahead and pause the video and try and do that. When you unpause it, I'll let you know what the answer is. All right, you've unpaused. Hopefully for that, you got 70. If you didn't, let me know. Okay, that's it for the video. We're going to do the practice problems together in class. I will see you guys next time.